Right, we're going to go ahead and do lesson 3, Intro to Logarithms. All right, so we've got a few things we're going to look at. The first one is just going to be the basic format. All right, notation. Log base b of y equals x. Notice the location and that this b is a subscript and everything else is on regular levels. So let's translate. Log base b of y is x. And that's how you would read the statement. Okay, so let's say log base 2 of 4. Okay, so this would say log base 2 of 4. Notice I left out the equals, and so we left out the is x part. Second thing we're going to do is we're going to rewrite. Okay, so we have the log format, and that's what we're going to start with. Log format, exponent format. All right, log base 25 of 5 is x. In order to rewrite this, we're going to go ahead and start at the base. Okay, notice that the base is a subscript, and we're going to do a little spiral, and we're going to turn this into an exponent format, and we're going to take the base. This is still going to be the base, but this can be an exponential that I'm writing. And so right here, 25, the x gets pushed up to the exponent slot, equals 5. We're not solving anything, we're just rewriting it. So we're going from the log format, log base b of y equals a, into the exponent format. Now it would be b to the a power equals y. Notice when we do this, the base of the log is also the base of the exponential. So let's rewrite a few others. Log base c of e equals 0. Okay, so I'm going to start at the base. Always start at the base. Swoop across the equals. C is the base to the 0 equals E. Let's try one more. Log base 1/3 of x equals -3. Okay, try to write it as an exponential. Okay, so you should have the base in parentheses to the -3 power equals x. Now let's see if we can go backwards, because all of these went forwards. Okay, let's see if we can go backwards. B squared equals 8. First thing I'm going to do is identify the base. Second thing I'm going to do is write log base b. And I'm going to put 2 placeholders in. And I'm going to try to figure out where each one of the 2 and the 8 goes. Okay, so I start by envisioning my arrows. Oh, the exponent goes on the other side of the equals, and then the 8. So it looks as though the 2 and the 8 switch sides. All right, try one more going backwards. 2/3 to the x equals 9/4. Log base 2/3 placeholders, swoop. Oh, they're going to switch sides. So to the x 9/4. Okay, now we're going to go to part 3, and that's going to be introducing some of the calculator notation. We have 2 special logs. One of them is called the common log, and this one is base 10. So you say log of x. Notice that I left off the base. These are all one level, and there's no subscript here. This implies that this log is base 10. The missing base will be replaced by a 10. This is called the common log. If you go ahead and look on your calculator, okay, here's your calculator, you see the LOG button right here next to the 7. That is the common log. Log. Notice there's no subscript here. So your calculator can evaluate logs for you. There are only 2 log values that your calculator has a pre-programmed button for. The other log is the natural log. This one goes LN. Notice here that there is no base, right? No subscript. However, I did not write the same LOG. I wrote LN. This is for log of natural base. Log of natural base. This can be rewritten to include the subscript E. The reason that we have base 10 is that we have a counting system, 1 through 10, and then we repeat. The natural base, E, can be used to predict and model population growths. Let's make a note of where these buttons can be found. Okay, so we have LOG. This is to the left of the 7. And then right underneath of that, you have the LN, and that is right to the left of the 4 button on your calculator. Let's go ahead and try that. Here we go. So right here next to the 4, you get the LN, which is log of natural base. Notice it leaves off the subscript. Now if you're looking for the number E, right here above the divide sign, second divide will give you the number E. If you look above the button right here, you see LOG, and then you see 10 to the X. That's a reminder that this is the log that matches the base of 10. Right here, you see log of natural base. In blue, you see E to the X. That's a reminder that this log is for the natural base E. Part 4. Let's start evaluating. We're going to start simple and progressively increase the difficulty. I'm going to write a sentence up here that helps. What exponent gets you from b to y? And we're going to write the general statement, log base b of y. Okay, what exponent gets you from b to y? Often, logs are described as exponents because we're asking ourselves, what exponent will get me from the base b to the value of y? Which means we are looking for the exponent value that will get you from the base b to y. Log base 4 of 16. Okay, what exponent will get you from 4 to 16? So you have to think of your powers. Automatically, I come up with 2. Now I'm going to switch colors here so you know that I'm evaluating 2. One way to think of this is by rewriting it. Think 4 to what exponent equals 16? Well, let's just go ahead and put in a placeholder. And then we can do the same base. 4 to the x equals 4 squared implies that x equals 2. And then the exponent is 2. Let's try a few others. Go ahead. That's correct. The answer is 4. You may rewrite it to help with this process. 2 to the x equals 16. 2 to the x equals 2 to the 4th implies x equals 4. Log base 3 of 27. That's correct. 3. Okay, this one's going to be sneaky. Log of 1,000. That's correct. 3. Let's look at how this works. The first thing I would do is I would write in the missing base, log base 10, and then I would rewrite it to help. 10 to what power equals 1,000? Implies that x equals 3. Notice that we are solving a simple exponential equation here by comparing matching bases to matching exponents. That's right. The base is missing again. Let's go ahead and write it in. Oh, 10 to what power equals 10? Well, that would have to be 1. Let's do maybe one more. Log base 4 of 1 equals. Okay, a little bit tricky, so I'm going to rewrite this. 4 to what exponent equals 1? Okay, think about those exponent properties. I know that if I can write this with a base 4 to the 0 is 1, implies x equals 0. Okay, notice that all of our answers are positive integers except for this last one. We're going to start increasing our difficulty a little bit. Okay. Log base 9 of 27. Wow. As I'm thinking about my powers of 9, 81, I skip over 27. That means this is going to be a power and a root possibility. Let's begin by rewriting this. 9 to the x equals 27. Okay, so 9 and 27 share 3 as a common factor. So I'm going to try to rewrite this with a base of 3. 3 squared instead of 9, and 3 cubed. This implies that x equals 2/3. Let's write that in. 2/3. Notice that it's a, backwards, 3/2. Right? Don't be too quick. Okay. 3/2. Let's write up a few more and see how you do. Log base 4 of 8. Log base 4 of, log base 64 of 4. Log base 10 nope, let's change that. Log base here we go. 1/4, 1/8. Okay. Most of these ones that aren't positive integers take a little bit of work. 4 to the x equals 8. 2 squared, 2 cubed implies x equals, don't mess it up, 3/2. 3/2. Okay, 64 to 4. Well, automatically, 64 is bigger than 4. It means I'm going to need a square root to go down in numbers. So 64 to what power gives me 4? Now, I might notice that's a cube root. I might not. So I'm going to start by rewriting this to the common base of 4 because that's a common factor. Implies x equals 1/3. Oh, fractions. Okay, so we have 1/4 with grouping symbols to what power equals 1/8. Okay, so really, if I'm looking at the corresponding parts, I'm looking at the 4 and the 8. Okay, so 2. 2 is the common factor because that's the repeated one. So we've got 1/2 squared, okay, 1 squared and 2 squared. And then we've got 1/2 cubed implies x equals 3/2. Notice that all of these different numerical combinations resulted in the same answer. Let's increase the difficulty slightly more. Notice that all of our answers have been positive integers or fractions. ln 1/e. Oh, Okay, first thing I notice is that the subscript is missing. Now to begin with, I'm actually going to rewrite this and I'm going to input the missing base. Now, we shouldn't write L-N-E. You should really write L-O-G, base E. Log base E. Okay, this is the quantity I'm going to rewrite. So E to what exponent is 1 over E. So that's really just the reciprocal. Negative 1 is the power. That gives you the reciprocal. Log 1/10. Oh, I'm missing the subscript. Logs have 3 parts here. You can't leave the subscript off unless it's the natural log or the common log. I'm going to write it back in just to do the problem. 10 to what power equals 1/10? Yet again, negative 1. Okay, let's keep going. A few more. Log base 3, 1 over 27. Okay, 3 to what power equals 1 over 27? Well, that means 3 to the x. The reciprocal is the negative power, implies that x equals negative 3. We are almost complete. Let's just do a couple more. Log base 25 of 1 over 125. Okay, so I see 25 and 1 over 25. First thing I notice is that 125 is bigger, but it's also a reciprocal. Okay, so equals 25 to what power will equal 1 over 125. Okay, so 25 and 125 have a common 5 as a factor, so I'm going to try 5 as the base. 5 to the negative 3. The negative gives me the reciprocal, so this implies x equals negative 3 halves. Log 1/4 of 32. Notice that we have a fraction and a whole number. That's a reciprocal combination. Go ahead and try. One-fourth to the exponent equals 32. Well, 4 and 32, so let's go with the common base of 2. So this is 2 to the negative 2 power, and 2 to the 5th implies x equals negative 5 halves. At this point, we've gone through positive integers, fractions that are positive, 0, and negative integers, and negatives that are fractions. Let's go ahead and sum up the special values. Log base b of b equals log base b of 1 equals b to what power gets me b? That's a 1. Okay, log base b of 1, b to what power will equal 1? That's 0. These two values are something that you should commit to your memory. let's look at the next statement. Given log base b, notice the subscript, of a equals, let's say, x. Let's make a couple statements. B is greater than 0. X is a real number. Okay? That's anything on the number line from negative infinity all the way to positive infinity, 0 in the middle. Can A be less than 0? And give a reason. Press pause and then play it when you're ready. The answer is no. Because no exponent can make a negative. Think about the results of the base b and all of its possible exponents. Okay? B to the x. You get reciprocals 1 over b cubed, 1 over b squared, 1 over b. 1 b squared. All of these possibilities, you're never going to get a negative outcome. That way, A can never be negative. For example, log base 3 of negative 9 does not exist. Not possible. It cannot be evaluated. Okay, let's do the last section here. We have this thing called change of base. This can be useful for a bunch of different reasons, but for right now, it's used for rewriting our log equation. So this is section 5. The change of base formula says log base b of x can be rewritten into a new base of your choosing. Notice where the two parts go. Okay, so we've got base here, and we've got the x here. It's going to turn into a fraction, and we're going to say log base k of x over log base k of b. So we kept the x moved to the top parentheses and the b moved to the bottom parentheses, and we chose a new base of k. Notice that the k was not in the original problem. Now we can rewrite this in any new green base. Typically, this would be used to write it with the common log or the natural log. Notice that when I write both of these, I leave off the base because it's implied to be there. Right? That would be base 10 and base e. Why would we need this? Let's go back to evaluating. Log base 1/9 of 27. Now I recognize that 1/9 and 27 share 3 as a common factor. So I'm going to change this to base 3. "27 goes to the top, and the 1/9 goes to the bottom. And from here, I can evaluate the statements. Log base 3 of 27 is 3. Log base 3 of 1/9 is squared and reciprocal. Squared and reciprocal. It allows you to evaluate logs without having to rewrite it and create a separate equation. Let's try that one more time. Log base 8 of 1/32. Choose a base that you can convert this to. Well, 8 and 132, so I'm going to choose not 4 because that's not a repeated factor. I'm going to choose base 2. Okay, notice the base 2 is something that you're going to have to pick. Now, the 8 goes to the bottom, the base to the bottom, and the 132 to the top. Okay, 2 cubed is 8. And then 2, what power gets me from 2 to 132? So that's reciprocal and a 5th power. Notice the negative gives you the reciprocal. And finally, let's solve. Simple log equations. Okay, let's begin with natural log of e squared equals x. Now that is an x equals equation, but does this side simplify at all? And so I'm going to start with writing in the missing base and see if I can simplify this at all. And I'm going to start with one strategy, which is going to be to rewrite in order to try simplifying. And so I'm going to get e to the x equals e squared. And I end up with corresponding parts of the exponential implies that x equals 2. Let's try again. Natural log of cube root of e equals x. Now I know that's an x equals, but does this side of the equation simplify at all? Let's start by writing in the missing base and then rewriting it into the exponential format. E to the x equals cube root of e. Now don't mix exponents and radicals, so let's convert this right side to an exponent format. That's a 1/3 power. Oh, that implies that x equals 1/3. Matching bases implies the exponents are the same as well. Let's try changing the location of the x. 2 times natural log of x equals 8. Well, the x is here. I do notice that this times 2 is on the outside. So as I rewrite this, I'm going to write log base e of x equals 4. I'm still using the strategy to rewrite it to see if I can find x equals by itself and make sure that if I have x equals, it's in a simplified format. E to the 4th equals x. Oh, rewriting it actually solved for x. Now, I'm going to leave the power as is because e to the 4th can't be simplified. I could just convert it to a decimal number. Let's try log base root x of 7 equals 2. We are still rewriting as our strategy. Root x parentheses squared equals 7. Well, the left side simplifies to just x equals, which solves the equation. Let's go ahead and try a few more. Log base 2 of cube root x equals 5. Well, x is here. The only thing I can try is rewriting this. 2 to the 5th equals cube root of x. Well, don't mix exponents and radicals. So how do I undo cube root? Let's try cubing both sides. Power to a power says multiply. Do not multiply out the number that is more than 100. Okay. Log of 1 over b of b cubed equals x. Now, you are solving for x. Start by rewriting it. Almost corresponding bases. Let's change the left side. Implies that x equals -3.